Solving Exponential Equations by Audrey Rubart and Aisha Zutter. Exponentials and their inverses. So an exponential function is any function with a base of a number raised to an exponent of a variable, such as x. So the main exponential is y equals e to the x. So the inverse of an exponential is natural log of x. So this is just basically log base e of x. So the fact that they're inverses, we can see that on the graph because here's e to the x over here, and then here's natural log of x. As you can see, they're reflected across the line y equals x, and that's how we can tell that they're inverses. This relationship can be showed algebraically by using this function to prove inverses. So f of g of x equals g of f of x, which equals x. So if we do this and we set that this is f of x, the e to the x equals f of x, and the natural log of x equals g of x, we can prove their inverses by saying that e to the natural log of x equals x. This is because these cancel each other out. E to the natural log of x cancels it out, and you end up just with whatever the log was doing, which is just x right here. This property also works the other way. So if we set natural log of e to the x, it will also equal x.
So we'll have to use logs when we're solving exponential equations. So we're just going to do a quick review of some logarithm rules. The first one is this multiplication rule of log base b of m times n. This equals log base b of m plus log base b of n. Remember, these properties and rules are also inverse. Can be used the opposite way. So if you have log base b of n plus log base b of n, you can multiply the constants. Our next rule is log base b of m divided by n. So this is rewritten as log base b of m, minus log base b of n. Next rule, which I think will be the most important and useful in this tutorial, is log base b of m raised to the nth power. This is the same as log base b of m times n. So this exponent just brings down in front and is multiplied like another constant. This last rule is when you have the base b and then you have that same constant in the function. This just the log base b and the b cancel each other out, and so you're left with x.
Here are some things that you should keep in mind when solving exponential equations, or just things that you should look for that will make solving them easier. So the first is same bases. So if both sides of the equation have the same base along with the exponential, then you can just set the exponential equal to each other. So you're going to see this in the following example. The second thing you should keep in mind is logarithms versus natural logs. So natural log is just like a regular logarithm except that it's base e. So this is just useful when you're solving an exponential with a base of e. So if e to the x or e to the something is present. That way you can just easily cancel the e out by using natural log instead of regular log. The third thing that you should always keep in mind is that the logarithm of a number, or the natural log of a number, is just going to be another number. There's nothing to solve here. It's just going to be a different number. So if you have the natural log of 24, for example, you're done. You found your answer.
Okay, for all these examples, I'm going to use using natural log just because of preference. And I'm going to show you in this first example why you can just set the exponents equal to each other when you have the same bases, these two. So the reason why is, let's say I wanted to get this exponent down. So I'm going to do the natural log on both sides. Using properties of logs, I can bring the exponents down. So I'll have 3x minus 4, parentheses, times natural log of 8 is equal to 5x plus 10 times the natural log of 8. So now if I wanted to get this exponent alone, I'm going to divide by the natural log of 8 on both sides. And when I do that, this cancels with that, and that cancels with that. Then you're just left with your exponent. So instead of having to do all that work, you can just set them equal to each other in the very beginning. So let's start to solve this. So if we have 3x minus 4 equals 5x plus 10, I'm going to subtract 5x from both sides, get the x's on one side, and then I'm going to add 4 to both sides and get all the constants on one side. So we'll continue this over here. So now we'll have negative 2x is equal to 14. To get x alone, we're going to divide both sides by negative 2. So then x equals negative 7. Alright, this is the next example, and since these bases are not equal to each other, we can't set the exponents equal to each other. So we'll have to just use our logs. So I'm going to do the natural log of 8 to the x plus 2 is equal to the natural log of 16 to the x. We can bring our exponents down, so we'll have x plus 2 times the natural log of 8 is equal to x times the natural log of 16. Now remember, natural log of 8 is just another number, so we can distribute this back in, FOIL it back in. So we're going to have x times the natural log of 8 plus 2 natural log of 8 is equal to x times the natural log of 16. Now to get all of our constants on one side and all of our variables on one side, I'm going to subtract x natural log of 16 from both sides. I'm going to subtract 2 natural log of 8 from both sides. So now I'm going to continue this over here. We're left with x natural log of 8 minus x natural log of 16 is equal to negative 2 natural log of 8. So now we can actually factor out our x's on the left, so I'm going to do that. So we'll have x times the natural log of 8 minus natural log of 16 is equal to negative 2 natural log of 8. Using properties of logs, we can simplify this inside function right here, so it can be x times natural log of 8 divided by 16. So now we just have one natural log, which makes it a lot easier to handle. So now I set that equal to x natural log, 2 natural log of 8, excuse me. So now to get x alone, we're going to divide by natural log of 8 over 16. But 8 over 16 is the same as natural log of 1/2, so I'm just going to write that as it's because it's simplified. Just keep in mind that natural log of 1/2 is the same as natural log of 8 over 16. And we're going to divide this side by natural log of 1/2. So now we're left with x equals negative 2 natural log of 8 over the natural log of 1/2. That's our final answer. Okay, so this next example, we have e to the 0.34x equals 50, but we also have it times 12. And I just want to get e alone for e's, so I'm going to divide both sides by 12. So now I'm left with e to the 0.34x is equal to 50 over 12. Now we're going to do the natural log on both sides. And remember, the natural log is log base e, so when I do natural log of e to the 0.34x, and then you have to do it to both sides, so natural log of 50 over 12. This natural log cancels with this e, and this is brought down due to properties of logs. So we have 0.34x is equal to the natural log of 50 over 12. So now we're just going to use algebra and get x alone. So we'll just we'll divide both sides by 0.34. So now we are left with x equals the natural log of 50 over 12, all divided by 0.34. And we can leave that like it is, because natural log of 50 over 12, again, is just a number. Thanks for watching.